April 25th, 2016. Baz, this recording is for you. I'm going to go ahead and read it out to you. Stars are born in planetary nebulas and start out really hot and energetic. They are called white dwarfs. To dissipate the heat and cool down, they expand greatly to become blue giant stars. Once they reach the blue giant stage, they begin contracting and cooling as the mass is lost. This is the beginning to the greatest, most intimate, most meaningful process in the heavens, the formation of a life-hosting world. Sirius A and Sirius B are a good example of this process when the star is born. The planetary nebula has already dissipated on Sirius B. This is the younger star, and this is the older one. Establishment science would like you to believe that this is the end result of a star dying, a really, really, really hot, condensed ball of matter that radiates very, very strongly in ultraviolet light. That's not an old dying star. That's a very, very young star. This is a star at the very beginning of its life. Over time, Sirius B will expand very greatly and become similar to its sister star, Sirius A, which is a much older star, and it's dissipating the heat away as it cools. Obviously, stellar metamorphosis goes over once it reaches Sirius A. It will move down the line, cool, condense, contract, and eventually leave a little ball called a planet. Actually, I should say all these are considered planets, because at about this stage right here, about this stage, they stopped shining. This would be like where a brown dwarf is, and then they become the planet. So star, they're very, very ancient structures that require many billions of years to do what they do, and they are individual structures as well. They're not related to each other. Maybe they could form in similar areas or at similar times and then take up orbit immediately around each other, but that's about it. Now, I came up with an idea earlier when I was at work. I don't know if this is correct or not, but I used one of those post-it notes. I thought this is pretty funny. Well, you have your birthing, and you're above the Chandrasekhar limit. Now, when the star is born from a specific amount of mass, this is a 1.39 masses of the sun. That little dot with the circle is a symbol for the sun's mass. If it's born with above 1.39 solar masses, it will then expand. It says star becomes large blue giant and expands, beginning the cooling. And cooling in that regard would be expansion, just like in regular thermodynamics. When you have a gas that expands, it cools down rapidly. On that same note, if it has below 1.39 masses when it was born, it will contract and begin pulsing and becoming a pulsar. I don't know what the mechanisms are behind that. Not gravitational waves, but literally, I think something to do with gravity waves are involved. And I wrote here, this is very, very fringy, so keep in mind. I have so hot temperature has no meaning because atoms are no longer bouncing off each other and it's too dense. So to say these objects have a temperature, the pulsars have temperature, is to be a little out there as well, because in order to have temperature, you have to have molecules bouncing off of each other and going random ways. But if the molecules aren't bouncing off of each other, if the elements are just stuck together, how is there going to be any temperature? Even if they vibrate slightly, you can't really get a temperature out of that, especially when they're really, really dense, closely packed together. And they became something like maybe a giant atom. I don't know. That's really fringy stuff. But anyways, I just wanted to show you guys that. That's where my mind is headed. Look up Chandrasekhar limit, I think, N-D-R-A. Chandra, S-C-K-H-A-R. I think that's how you spell his name. But apparently he was ignored, and Einstein gave him his due, because he was in India at the time and everybody ignored him. But anyways, this is an idea that I think would be really cool to look up. Also, keep in mind, they like to introduce black holes. Black holes. This isn't suitable, because a black hole is a phantasm. Those have never been observed directly or indirectly. I'm pretty sure that this is pseudoscience in its purest form. So just ignore that. I would go more towards, if anything, neutron stars or magnetars, which are really, really, really high or really powerful objects that have huge, very, very strong magnetic fields. Alright, but that about sums up this talk. Hopefully I didn't make it too long and show you guys where my mind is headed. Baz, if you need me to redo that statement, just let me know. Alright, later y'all.